Perfect. Appreciate everyone joining the call today and those who are listening on the recording. My name is Ryan Sloan. I am the vendor business manager here at Ingram Micro for IBM system, which includes power, storage, and TLS. Have some great content today. We have Todd from IBM who's going to be discussing a little more detail the new flash system C200 that was announced, and IBM ran some calls in late February on it, and then do a flash system grid technical overview. So we have a couple exciting topics. Todd has a lot to go over today, so I'm going to turn it over to him and let him get started.
Great. Thank you so much. It's a real pleasure for me to be here with Ingram Micro. I have kind of a history with you all. I was a VAD person back in the day, maybe about a decade or so ago. And so I believe it or not, I do miss coming to Buffalo in the winter. I do like winter. I'm one of those guys from up north. So I know that sounds crazy, but you can take the snow out of the guy, but you can't take the guy out of the snow, I guess. Um, so this morning we're going to go through a couple of different things. We're going to kind of talk a little bit about just storage virtualize in general and kind of the state of resiliency, those sort of things. And then we'll introduce you to the C200. And then I've got a bit of a primer on FlashGrid because I know, or I shouldn't say FlashGrid, Flash Systems Grid with the small g. So you'll see that referred to as Flash Systems Grid moving forward as well. So when we look at just resilience overall, I think you guys probably are familiar, or many of you are familiar with some of these statistics. I think the big ones for me are the fact that most people have either been or are infected, and then really on top of that is they don't even know they're infected, right? So, as we speak about resilience, that's those things that we talk to clients day in and day out. If they've had a cyber incident, more than 60% of them actually close within 6 months. They either don't get their data back, or yeah, as the result of it, they've lost so much business, those sort of things. And so some of the other averages that we have in here in terms of the average cost of a ransomware attack is slightly higher here in the United States, but that's an average across the world, or across all geographies. But in America, it's actually more or closer to about $10 million is the cost of a ransomware attack. So, from a background perspective, you either know your data and know your business, or you don't have data and you have no business. And that's really what it comes down to. And so storage is really becoming increasingly more critical when it comes to detecting and responding threats. And so IBM's got some unique technology that we help our clients by default usually help them to do that detection early and often. Storage integration also is kind of in its infancy when we look at putting it or integrating that with things like a SIM or a SOAR engine, or with Ansible and some of the other tools that we would have out there to help automate the integration or automate different storage functionality. And then finally, like all of our clients that we have out there, very few of them have one single vendor. And so they've got data stored across all different uh, vendor storage. They may have vendor storage for one particular application. They may have another vendor for another application. They may have multiple different locations across the globe. And so trying to get or locate that data and then utilize it efficiently then becomes a challenge. So some of the key design points as we move forward just in storage in general, and we talk about flash system, at least I'm a very myopic from that perspective. So storage has got to really be able to perform. It's got to be very scalable, and it's got to be easy. And ultimately, we used to have a Venn diagram where we'd have kind of three of them in the intersection point, and you could usually get two of the three there, and never the third. But Flash really and Flash core modules bring that to us in a different way. So we can be performant, we can scale, and it can be extremely easy. So there's a lot of added value then, especially when we're looking at a resilience posture out in the infrastructure. So where would we start when we talk to customers? And this works for some, but maybe not all of them. But IBM has a process that we call security and resilience assessments, or it used to be CRAT. Some of you may have known it as CRAT. We've taken the NIST 800-2 framework and wrapped it around with the governance that they've added to it. And so we would take clients through the identifying things in their infrastructure, how they're going to protect them, whether that's access control or if we're talking about different hardware functions and features, the way in which they're going to detect and what they're going to do with those sort of anomalies, how they're going to respond, and then finally how they recover. And so, why do we start here? It's because ultimately we want to establish a baseline, and that as they integrate IBM technology into their infrastructure, then as we go back and we review some of the Sarah components with them, they can show actual metrics, they can show actual progress in and around innovating with IBM infrastructure. I've been asked on many occasions, does IBM storage comply with NIST 800.2, or is it ISO 27001 compliant? And when we look at the different components, the 5 components, including then the 6th of governance, IBM has what we call an operating resiliency chain. So if you kind of zigzag through that, if you start on the upper left-hand corner there from intelligent monitoring, looking at our systems doing things like storage insights, and then the management capability that we bring to bear, whether we're talking the element manager or even Insights Pro, and then our integration into SIM and SOAR capabilities that they may or may not have. And then first line defenses like keeping the bad people out in terms of role-based authentication, MFA, TPI, those sort of things. And then backup. Obviously we're talking about Defender and integration into those sort of things. And then threat detection that we have built into our FlashCore modules and storage virtualize, the availability capability that we have, and we'll talk about FlashGrid and how that will enhance that ability, as well as from a migration perspective. And then how quickly are you going to respond? Ultimately, the biggest barrier that I think most clients face today is the decision tree. How quickly do they actually respond to something like that? Sometimes it gets caught up in analysis paralysis, and instead of being able to react within seconds, minutes, moments, it takes hours and days and sometimes weeks to actually do that recovery. So IBM's got a methodology utilizing safeguarded copy or immutable copies, as well as our FlashCore technology being able to detect, and we can combine those together then to provide very, very short windows in terms of detection of an anomaly, as well as the recovery of an anomaly. So the answer to the question is, are we compliant with 800-2? The absolute answer there is absolutely positively we are. And we're building and we're maturing our product line in conjunction with the NIST parts of it. Now, NIST has actually adopted some of our encryption capabilities, especially in and around quantum safe encryption. And so those are going to become part of that standard as well. So I'm going to throw a question out here. What if all your business objectives could be met and your complexity reduced? So IBM really, when we look at storage virtualized and we look at the hardware platforms that we have within the portfolio, it's really forget about your storage, right? Let storage virtualize and FlashSystems just do it. Combine together the software and the hardware package, the solution together then allows you to mobilize workloads quickly, non-disruptively, migration, those sort of things. And then you can refresh as needed. We can optimize that capacity when we're looking at things like utilizing SI Pro to tell us maybe a better tier of storage, those sort of things, but also in terms of optimizing capacity, utilizing FlashCore modules and our compaction and compression. And then if you're looking for things like deduplication, we can provide that then with data reduction pools. And then ultimately you want to be able to control this and not have to reinvent the wheel every time you want to do this. So Insights and some of the software that we put together with our offering then focuses then on the service level agreements, and they're assisted using the AI that's built into the user interface. And so we can make recommendations, we can predict, and we do that all with analytics that we send up continuously from the controller to our lake house architecture utilizing SI Pro. And then ultimately uh, uh, we want to defend this consistently. So we can provide guaranteed operations like 60-second recovery, and then even we'll guarantee a 60-second detection within a flash system today. So now if you wrap your arms around that and say, I could put a flash system out in front of other people's vendor storage, now we can also provide them then that ransomware threat detection and those sort of things as well. So, it's the forget about it storage. It unlocks a lot of value and will guarantee it. So, you can utilize your assets up to 80%. That's one of the things that when we look at storage virtualization is being able to take and put your arms around your storage, very similar to what VMware does with a single server and slices it up into multiple little virtual servers. What we do that is in kind of reverse. We take all of that storage, put our arms around it, and we make it look like a blob of storage that you can utilize then well above. We've got customers that are utilizing it well above 80%. So what does that do for you? Ultimately, no downtime, non-disruptive data movement, and especially as we talk about flash grid here in a moment, you'll see where that becomes very, very important. Capacity optimization, all flash arrays, and we start looking at things like the endurance of our modules, especially compared to the industry common off-the-shelf QLC technology. We're talking 3.7 times the endurance of what you would get from an industry off-the-shelf QLC. So our competitors in the marketplace when they're using QLC, and they do have some endurance issues as things age. Um, and we do actually offer no write limits on our media. So we've never really wore one of these drives out. You want to be able to control it very simply. And really that's where the TCO reduction comes in terms of the man hours, in terms of looking at the amount of time it takes to manage your system. And then we augment that. We help that obviously with AI ops and using things like storage assurance in terms of providing you the means then to keep modern whenever needed. And so you can replace that system whenever you need using storage assurance. I've got a slide here we'll talk about here in a second. And then ultimately from defending consistently, we're looking at the detection. Where do you want to detect? We're going to detect on every IO within the box, and we will report back on that in as few as 2 seconds, but we'll guarantee that if there is an issue with it, then we will report in 60 seconds or less. And if we have a copy that we can recover from, we can recover from that in less than 60 seconds as well. So kind of just to put our arms around this, what if you could, by utilizing data placement and optimization, unlock 20% more capacity? Would that be something that clients would need or want? What about 40% less effort in terms of just automating and minimizing that time to do things like planning, provisioning, and management? And then what happens, what if I could offer somebody 100% application availability and uptime? I think most people are still in the 99s. IBM will give you 100%, depending on how you configure your system. And we'll guarantee that. We'll guarantee that for the end user that's there. So how would you consume this? How does IBM provide the ability to consume our flash products or our storage virtualized software? We've got 3 different ways that we can do it. One of them that's not here would be is we do have bring your own licenses. So you could set up an instance in AWS or Azure or even in the IBM cloud. But we have 3 ways that we can physically deliver it. There's a perpetual, which is storage assurance. And so if you were going to equate this, there's many other vendors that have similar offerings to what IBM is doing, and essentially what you're looking at is that the depending on how you want to put this into effect, you can get free hardware, new hardware, upgraded hardware, and you'll never go nothing will ever go end of life on you in terms of the perpetual or the storage assurance capability that we provide. We have utility and as a service options. They're both kind of lease options. Really, the difference there is utility option. You have the opportunity to pick your own controller and configure it the way you want, and then pay a base license for that. So there's a base amount of capacity that you'll pay for. And then as a service is really a turnkey IBM operation. So you tell them how much storage you want, the performance characteristics of it, and IBM puts a fully blown out system there, and IBM takes care of it soup to nuts. So whatever way that a client is looking at actually utilizing, whether they want to utilize do something with bring your own license, or if they want to do storage assurance or provide some sort of OpEx models rather than a CapEx model, then they can do that as a service or a utility as well. So let's talk a little bit about what IBM announced here on the 25th of February a little bit. We announced what's called the System C200. So the C denotes capacity. So IBM is kind of doing what most folks are doing in the industry. We're providing a capacity or a general purpose secondary storage device. It's based on IBM's FlashSystem family hardware, as well as utilizing things like our FlashCore technology as well. So it's a 1.1 petabyte raw. And so when we look at in a 2U, it's very, very dense. There's one or two that have slightly more density than in a 2U from a raw perspective. But it really is designed for higher capacities, not super low performance, but lower performance, say, than our standard FlashSystem 5300 line. This is a capacity, like I said, capacity configuration. And it really is optimized again for energy efficiency, capacity, and it's there to reduce the overall footprint as compared to, say, spinning drives. So there are lots of folks that are out there that need capacity, and in the past it's been a small bit of flash in front of a bunch of spinning disk, and that's what they've done. When we look at those hybrid configurations, they eat up a ton of rack space, eat up a ton of heating and cooling, and so something like the C200 definitely fills out the enterprise here. Again, full enterprise data storage services, so all of the software that you're used to in terms of storage virtualized is there for you to use. And we don't have any endurance drive or a limit on the drive writes per day. So you could fill these up every day, and there would be no performance impact to it, unlike common off-the-shelf NVMe drives today. So clients do need that low cost, high capacity to replace that hybrid system maybe that they have in there today. But they don't really want to compromise on the modernization in terms of, do we want to really keep SAS spinning HDDs that are out there? No one's really making any NVMe spinning disks. But so do you want to compromise that modernization effort that you've got going on in your enterprise? So in this case, IBM came up with the C200. And it sits right alongside the rest of our flash system that are out there. It's a FlashCore based uh, configuration. It's a hard configuration, so it comes in one configuration only. There's a very few things that you can actually choose or pick on here. I mean, interface cards obviously would be one of them. But when you talk about capacity and you talk about the cache and those sort of things that people normally would configure, those are fixed configurations in the C200. So if you're looking at clients that have these kind of hybrid systems that are out there that maybe have anywhere from 500 terabytes or larger, this would be a really, really good box to substitute, and you'd save an abundance actually in terms of rack space and cooling and performance, those sort of things. And again, 5300, 7300, 9500. So if you look at small, medium, large, or baby bear, mama bear, papa bear, whatever way you want to look at it. And they all contain our fourth generation FlashCore modules, which allows us then to do things like ransomware threat detection on every IO. Now, I don't want to slight anything, but the SAN volume controller is still up there. That's the granddaddy of all of our software-defined storage that we offer today. So if you look at some of the other product lines like Ceph Fusion and Scale, from a software-defined perspective, the SAN volume controller is kind of the granddad of them all when it comes to storage virtualization and software-defined. And again, runs on the same storage virtualize and storage insights across the entire fleet of our controllers. So everything that we put out there today, so it makes it very easy from a product set. So as you look at our product set compared to maybe some of the others in the industry, they may have 4 or 5 different types of storage to get the same benefit that you would in a flash system. So let's look at performance and positioning real quick here. So we look at the upper left-hand side there, and we look at the flash system, if that's a 50-15, 50-45, 50-30, 50-35, those kind of configurations that we have out there. A hybrid configuration was roughly about $100 a terabyte. The flash system 200 is about 2.5 times that more expensive. However, the metrics or the performance that you get from this box are well over 2.5 times what you would get from within a hybrid configuration. And then if we compare it across the line in terms of a 5300, 7300, and a 9500. Now, again, these are rough numbers. These are not numbers that I would go out and actually sell to a customer. This is to just give you a uh, I guess a comparative in terms of where it would fit from a price perspective in there. So as we look at kind of the bandwidth of the box, definitely 2 times faster than a 5045, almost got the bandwidth of the 5300, and it's about half of that of a 7300. Now, if you looked at the FSC 200 and the 7300 side by side, and I pointed them toward you or pointed the back towards you, there would be no difference, right? So the FCS 200 is a flash system 7300 that we've put in some different processors in there, and we've tuned the bus differently to be better from a sequential or a lower end sequential perspective as compared to the hybrid systems in the 55 5015 scenario. So as we look at just the specifications, 1.1 petabyte raw fixed capacity, and then we can get up to 2.3 petabytes if we're looking at effective capacity after we do things with RAID in terms of a 3-to-1 in there. It's got the full set of storage virtualized form, function, and features. The cache is locked at 256 gigs. So in a 7300, you could get about 4 times the amount of cache as you can get in a 7300. We do have 8 10 gigabit onboard ports. So if nobody wants to put in additional adapter cards, but we can add 16 ports of 32 gigabit fiber channel, or 8 by 25 10 gigabit Ethernet ports as well. And we can even put the SAS card in here as well if somebody wanted to expand that and put expansion trays behind here. And then ultimately, it's got 10 times the performance than a hybrid system. And it really is optimized kind of for sequential workloads. We'll look at that here in a second. So ultimately, powered by virtualize, it's fifth the rack space, a fifth the power, 10 times the performance. Very, very miserly in terms of the power, so 0.9 kilowatts per hour to use that. Still has ransomware threat detection and safeguarded copy guarantees in here. And it's flash system grid enabled. And we'll talk about that here in a few minutes. So if we're going to position this then by workload, you'd see then the C200 really is for kind of backup, disaster recovery, general purpose storage, maybe where you've got workloads that really don't have critical response time needs, 1 to 2 milliseconds. Now, the rest of the industry is utilizing the common off-the-shelf NVMe QLC type drives. They're getting 3 to 5 milliseconds. So when we look at performance, even of our capacity optimized boxes, we're generally getting 2.5 to 3x the performance of our competitors in this space. And so as we work ourselves up in terms of the 5300, 7300, 9500, you can see we go to mixed workloads, mission critical applications, and again, super high performance. And we're talking then the amount of physical storage that we can put in a 5300. So 12 drives, 24 drives, 48 drives, and a 9500. So again, small, medium, large, baby bear, mama bear, papa bear. And again, Everything is monitored by Insights Pro or Insights, and it is running our software-defined storage virtualized operating system on the system itself. So how does this compare to our competitors here in the market space? So as we start looking at things like the Pure C70 or it's the Flash Array EG1, you can see then as we start looking down, I guess the proof in the pudding is the dollar per raw terabyte. Now you're going to notice that IBM is going to raw terabytes. That's not something that we have typically done in the past. Every other vendor quotes raw price per terabyte, and we're going to go that, and I'll show you kind of how we calculate that as we go forward. Because as you look at I guess the fourth line down there, we have 24 46 terabyte drives. And I know some of you are going to ask, oh gosh, we've come out with a new flash core module. And the answer to that is no, we haven't. It's still our largest, our XL module. It's just we're quoting the raw capacity of the module rather than the usable capacity of the module, which becomes important in terms of the price per terabyte. So you can see across the board, with the exception of possibly the flash array, IBM comes in at a very, very miserly $174 per terabyte of usable space then, or of raw space, sorry, in the controller. Now, many of you are going to ask for this deck, and I've given the deck and everything to Cheryl and to Mark, and so you can have a copy of this, and you can look it over at nauseam after the presentation. This is really kind of the front and the back view. So the top there, the top view here, as you're looking at, these are where all the flash core modules will be plugged in here. Now, when you configure this box, you'll notice that when you configure it, you don't have the option to pick drive size or the number of drives because it is a solid hard capacity. It's going to be 24 drives that are going to be our largest or our XL size flash core modules in there. One of the big differences between this and say the 7300 is that we're only going to offer the ability to use 2 adapter cards, and that comes from the fact that we've taken the 2.3 gigahertz processors out of there, and we've put in a 1.7 gigahertz processor, and then we're limited at that point by the PCI Gen 3 bus that's within here. So as we look at the different things, here's where your IO adapters would go here. So these would be some of the options that you could pick. And then you've got kind of the data at rest encryption keys. Just as a side note, you don't necessarily need to order the USB keys with your encryption license enablement. We do support the internal key manager within the flash system today. So that helps in terms of a lights out data center. The purple then are the host connections that we have here on the controller itself. And then the battery backup modules and everything are for the most part the same across the 7300 and the C200. So here's an internal block diagram. If you look at kind of the bottom where I've got that blue around one of the canisters, what I've done in the block diagram, I've blown up that one canister so you can see kind of how the internals of the physical controller are there. So we are still using the Lewisburg and the quick assist tech or the quick assist engine that's there to help us do things like compression, if we're going to use data reduction pools, those sort of things. We do have DDR memory. Again, the CPU is a Cascade Lake, and it's a 1.7 gigahertz. So we've got 2 of them per module. So we've got 4 physical within the controller itself. Each of the controllers then will have 128 gigabit or gigabytes, sorry, of DDR cache per node, and then per enclosure. So the entire enclosure, as we look at this down here, the entire enclosure then would have 256 gigabytes of RAM in there. Now, that allows us to get full bandwidth of the controller as well as provide all of the functions when we look at things like doing policy-based replication as well. We do have some of the option cards. We talked about them before. And then again, I just want to reemphasize that this is a fixed capacity. So it's coming with 24 extra large flash core modules in there. This is just kind of some of the hardware feature set that we have within the system itself. And you guys can go through this. Really nothing shocking here. I think we talked about most of this. I think one of the only things that might be slightly different is that the D-RAID 6 of the configuration, that's a fixed config. So we, instead of going to, as a default from a D-RAID 6, a 10 plus P plus Q plus the spare, we're going to 14. So we're going to lengthen out the stripe there to get as much capacity out of the system as we can. And so that's a fixed uh, uh, characteristic two of the box, is that we're utilizing a fixed D-RAID 6 of 14 plus P plus Q plus the hot spare. Next one here, these are just more of the features and capabilities within it from a storage virtualized perspective. The slide before this was more of the physicals. This is more of what the software stack on top of it. And as you compare this with the remainder of the portfolio, you'll see that everything that we support on the others in the portfolio, we support here. These are just here to give you an idea of what's available, or if you've got questions on that, you can refer to the chart here. These are the different adapters that are available. So we have really only three adapters that we can do. Now, keep in mind, we have 8 onboard 10 gigabit adapters. And if you're utilizing, say, this for backup, or maybe you're utilizing this for some sort of iSCSI streaming or something of that nature, then that would probably be all you would need. But you can put 32 gigabit fiber channel in here. And we do offer both the long and the shortwave options there. 25 gigabit iWarp or Rocky Ethernet cards. Some of these are required to do things like mirroring. If you're looking at doing the mirroring, utilizing the Rocky Ethernet cards, that's going to give us the ability to do some things maybe a little bit different than we would with the 10 gigabit onboard cards. And so those are the options that we have available. Now, I stuck these next two slides in here, and we won't go through these, but you can go through these at your leisure if you'd like. But these are like utilizing a 6 terabyte drive as compared to a flash system using flash, the C200 using flash cores. And you can see that as you're looking at the capacity here, and then the compression rates that people would look at, the number of hard drives that would be needed, the rack space, and then comparing that then with the C200, and then the reduction overall. And you can see that overall, I mean, we're saving anywhere between, what's the lowest number there? In this case, about 79% all the way up to 90% of the power and cooling and rack space and those sort of things, as compared to a 6 terabyte drive use case that would be uttered. This is the same thing with 20 terabytes. And again, um, uh, uh, substantial savings that we can offer in terms of rack space and those sort of things. So the Flash System 2 or Flash System C200 then really becomes one of those backbone components of a flash system grid. And it really does enhance the value prop that you get with the software. So storage virtualized flash grid technology is part of the software. It's not something that you're paying for, but having something like a C200 is going to give us some a capacity tier there that shares the same real metrics as we do with our performance tier storage in our 53, 73, and 9500 models as well. So the Flash System C200, really, when I'm looking at this, when we say data repositories, that's kind of a nebulous sort of thing, and archive as well, and backup. But really, we're looking at utilizing this for streaming, medical imaging, multimedia. And again, if you're looking at backup and archive, this would be an optimum target for those kind of workloads. If you have clients that maybe do a lot of camera work where they have to save, like banks I know are very required to do this, where they have to keep a certain amount of video, or they've got to cover certain areas with video cameras. And so this would become one of those really good opportunities to then utilize this technology. And again, it's a petabyte worth of storage raw. So, I mean, configurable and everything like that. You're talking somewhere in the neighborhood of about 770 or so terabytes of usable capacity within the box. And so, very, very usable from that perspective. So, Mark, do folks have the ability to ask questions or anything, or have there been any questions?
We did put in the chat that they could ask questions there. So
Okay.
far, we have nothing.
Okay, so let's see if I can wake them up on the second half of here, right? So we're going to talk a little bit about FlashGrid. So FlashGrid's one of those things that we give away with the storage virtualized software itself. Now, the FlashSystem C200, any of our other FlashSystem controllers can take advantage of this, except for the very, very low end, the V5000, like 5015, 5045 are not able to participate in a grid at this time due to the fact that they just don't have enough cash to be able to do that. So let's look and see how, from a flash grid perspective. So how can data storage be less complex and have greater efficiency and provide industry-leading resiliency? So if you look at an IBM flash grid here, the flash grid is something that you create with different physical pieces of hardware. So whether you're talking about a FlashSystem 5300 or C200's 9500 SAN volume controller that's front-ending other people's disks, we can put that all together in a grid concept. So if you're familiar with how containers work, where you have kind of the essence of a workload and you can take and pick that container up and move it from place to place to place. This is what IBM is creating with our Flash Systems Grid. So Flash Systems Grid is kind of the joining of the hardware components. And then we've got kind of a middle layer in there that does the monitoring and the AI ops of the system. So we can take and pick up workloads and move them from different controllers non-disruptively. It can be used for doing migrations, those sort of things. We can then even create relationships between controllers to do things like high availability, or between grids and do things like a replication from an asynchronous or even a synchronous capability, depending on what that is. So you have the grid is kind of the essence, and then you've got the with the controllers, and then you've got kind of that middle layer that we'll talk about, and then you've got kind of that host layer that's got kind of all the hosts and host ports and those sort of things, and we can group those together and create movable containers, so to speak, or we would call them partitions within the flash grid. And we can even do this with non-IBM storage. So this is really a unique value that IBM brings to the table. So we can bring this intelligence in terms of the monitoring, the AI ops, those sort of things to all of our competitive storage as we need them. So we look at the three different layers, and I'm going to start at the bottom left-hand side because that's kind of where we start everything off. So we've got an infrastructure layer. So we're going to take things like flash systems. We're going to take things like the SAN volume controller, and we're going to package maybe even some of our competitors maybe behind these controllers or maybe behind the SAN volume controller. And then we can provide then that linkage there and the management capability between the components that we put within the grid. So there's the greater grid with all the hardware. And then as we take and configure that, we get into what's called the automation layer. And I've got some very animated slides that are coming up that'll describe each of these components in better detail, and you'll get an idea what we're doing. But we take and we put things like host and host ports and volumes into a partition, and that partition then I can just pick up, drag and drop it to another system. And so if you're looking at doing migration, or if you're looking at allowing the AI aspects of storage virtualized to calculate or to tell you where a better place maybe to put this hardware or to put this workload is, now all of a sudden you've got a fully scalable, fully interconnected system that allows you then to utilize the infrastructure that you need. And then finally, we have the analytics layer, which would be run with Insights Pro. It's not the standard version of Insights, but Insights Pro. And then we would be able to use then the I guess, the telemetry that we have on the system to make intelligent decisions as to where workload is, or if we've got an issue maybe with ransomware, those sort of things. And then that they can predict things like the placement, where that would be best placed, and then optimize it not only for performance but for capacity. So that's one of the things that we can do, and that's not just across our gear. That would be across everything that would be in the grid. So let's define a little bit of terminology here, and then we'll show you kind of the physical aspects of the grid. Now, before, you heard me talk about um, raw capacity of a system. So what is raw capacity and how is that defined? The raw capacity of a flash core module, and that's what we'll talk about in this instance, is the total amount of 3D NAND flash that's contained within the module. So when you go into, say, like econfig, and you're looking at, say, a FlashSystem C200, you're going to notice the modules are going to show up as 46 terabytes. Why? Because that's the total raw amount of flash that's in that module. Now, if you took a 7300 and you configured the 7300 with the same modules, the 38.4 flash core modules, you'd notice that they're only going to show up as 38.4. Now, I've been assured that they're going to change that so that we're all looking at raw capacity when we configure initially. So the raw capacity is the physical amount of flash storage that's within that module. So we have two other components here. We've got usable capacity and effective capacity. So then the usable capacity then is the total flash capacity with the overhead needed for module health and monitoring. So there's an amount of flash that we set aside in each module, and we utilize that to do things like health binning, and to utilize in case that we do have a physical cell that wears out. We can program to be SLC cell or whatever. So that's the usable capacity. So when you take that raw capacity of 46 terabytes on a C200 and you plug it into the controller, what it's going to report to storage virtualized is going to be a 38.4 module, right? We're doing the raw capacity because it's a marketing, more of a marketing um, thing, so that we're just like, or we're reporting our capacity just like others in the industry, right? We were a bit too honest at times in terms of the usable capacity. So usable capacity would be plug that drive into a controller, and what is it going to report to the operating system, the storage virtualized operating system? It's going to show that it would be a 38, in this case, a 38.4 flash core module. So then what's the effective capacity? So the effective capacity of that module then is going to be the data reduced addressable capacity. So you could compress in this module at 3:1. Let's just say you don't fill up that module. Maybe the module is only a third or a quarter of the way. Am I limited by the capacity or by the compression that I can use? The answer is no. There's no limitation on the compression. The limitation has to do with the addressable metadata space for that module. So there's a point in time when we get to about 40% of the module being filled, that the maximum addressable space on that module is going to be about 115 terabytes. So that's raw, usable, and effective. So next slide, that you'll kind of see this laid out here a little bit. So as we look at the raw capacity across all the flash core modules, you're going to notice that we would, in the past, would have called this over allocated space. How much physical space or raw capacity is within that drive? And so like a 4.8 is 5.7. So we go all the way up to the large, or the XL module. That would be 46 terabytes of raw capacity. As we plug that into a controller, the usable capacity is going to be 38.4, because we set aside a piece of that flash to do the health and the monitoring of the physical module itself. So then when we look at the effective capacity, the only one that's really different in here would be the 4.8 or the 5.75 terabyte flash core module that we have. When you plug it in, it's going to show nearly 22 terabytes of physical space. And how do we get that? We have enough addressable metadata space to do 5-to-1 compression in the module. And that's the only module that we have that will compress that big. And so the remainder of them, whether you're looking at medium, large, extra large modules, that all do 3-to-1 in there, but it's limited by the addressable space and not by the algorithm itself. So when should we use these different terms? When would we use something like raw capacity? If we're going to compare to another vendor and they're saying, I can get X amount of storage in this kind of space, that's when I would typically do raw capacity. If you're doing things like an RPQ, or you're doing some sort of answering some sort of tech, I guess, a discussion with a business partner, or even with a client, and they're looking for what's the total capacity of the box, I would probably quote them raw. When we look at usable and effective, those would be depending on the situation, right? Usable capacity, this is what you're going to see in the user interface, and effective capacity is going to be that use as well. Now, within the physical user interface, I know this is going to sound crazy, but we're going from usable and effective capacity to physical and logical. Right. So those are going to become interchangeable terms. So are they interchangeable? Yeah, it depends on what term we're talking about here as well. So a couple of things that I did overlook here, when we talk about the encryption and the compression, those are all sort of things that all the modules are capable of doing, to include quantum safe encryption, which is a NIST 800-2 requirement coming up here pretty soon. And they've adopted IBM's capability to do it. So let's take that main picture back, and we talked about the physical drives that we would plug into these boxes. So we're plugging these boxes in, into our flash grid. And so this would kind of be that very bottom layer, that infrastructure layer that we have there. So you could put multiple different types of IBM flash boxes back there. You could front end then anybody using external virtualization. And now we've got this kind of a collection that make up our grid, right? So the flash grid then can be pretty much anything. So as we start looking at doing things like replication, I don't necessarily have to mirror from a 5300 to another 5300. I could mirror it to that C200, or I could mirror it to the SVC, or I could mirror it to anything that's in the grid. And so that's where the power of this becomes, right? So we have workloads, we've got the systems that we're setting up here in our infrastructure, and we're making a relationship between them. So let's look a little bit different in terms of when we do things on a controller, what that actually does. So when I've plugged that FlashCore module in, we go from that raw capacity to a usable capacity statement. And so if I fill out the remainder of the controller with FlashCore modules, then I can take and group those FlashCore modules together and create a pool. So when I create that extent pool, you'll notice that I'm calling it an extent pool. What is an extent, and how does that relate to IBM storage? So an extent is a logical component within storage virtualized that is the component of virtualization. So I'm taking and I'm going to take and stripe all the data in there, and I'm going to chop it up into addressable chunks. So within a physical system, we have 4 million of those extents available in the cluster. And those extents, or those little units of virtualization, those little addressed areas of virtualization, can vary in size from 16 megabytes all the way up to 8 gigabytes. So if you had an 8 gigabyte extent size, then you could theoretically address up to 32 petabytes worth of storage. So the addressable storage per cluster then, or per controller pair, excuse me, then would be the extent size times 4 million. Now, can you have varying extent sizes? Yep, but it makes things like pool migration and those things can be somewhat different, because it'll automatically migrate it to the extent to the place where you're gonna to migrate it to. So we've got this extent pool. So what I want to do now is I want to blow up that extent pool for you here and show you. Now we talked about that stripe, right? So we have 14 bits of information, or 14 of those physical extents, plus we do a parity, plus a quotient, plus a piece for the hot spare. And so this is how it would look when we populate this out on the system itself. So you'll look in the upper left-hand corner, we've got 0, 1, 2, 3, 4, all the way up to 14. Then we've got a P plus Q plus hot spare. And then we continue to do that all the way through. And that's really kind of what the extent pool looks like. Doesn't matter how many physical drives we have in there. In this case, on a C200, it would be 24 drives, but we would be striping that data across all of the different physical drives that are in there. And so those extents, then we would take and we would group those extents together. So we'd grab that and we would call that a volume. So when we take and we cut those out, those volumes then are created. And those volumes can then be assigned to a server if you wanted to do that. But in our FlashSystem grid case, what we're going to do then is we're going to take and mate those together. So we take those volumes, we put them together in what's called a volume group, and then that volume group would then be mapped to a host, and that host would be a server and its ports within the SAN. And so we put that in what's called a partition. Now that partition becomes mobile. We can take that partition and then move that partition to any other system that's participating in our grid. We can apply copy services to it. We can do lots of different things with the partition because it's participating now in the physical grid. So then as we look at this overall, we looked at the very bottom, we created our grid with the physical hardware. We created our automation layer here in the middle. We created the automation layer here in the middle. And as we created that in the middle, now we're able then to feed that up into Insights Pro, and Insights Pro can tell us things about our partition. It can give us decision points on our partition, those sort of things as we move forward. So that's kind of the big picture of what a flash grid is. So how does that go together? How does that match together with things like policy-based replication? So if we start at the very, very bottom here, and we look at the very basic part of this, safeguarded copy, immutable copies of our data, and then we could pair those and do things with ransomware threat detection, those sort of things. Those would be our copies that are very, very close within the same pool, those sort of things. We've got policy-based high availability. Many of you may know this maybe as hyper swap. We've got policy-based synchronous replication. And really the difference between synchronous and HA is auto magic. It will fail over and it will do everything automatically. Policy-based synchronous, there would be some manual intervention there to be able to utilize that. And again, these would go out to metro mirror distance, and it's really going to be based on the latency of the network link. We've got policy-based async, 3-site, and policy-based async. So 3-site would be I have a pair of systems, maybe in a metro mirror mirroring to another one, and then or we could have two in a synchronous relationship and a third site that that's going to make that third copy. So we're providing all of this using policy-based replication, which is something new with IBM. In the last year, we've been moving from the old Metro and Global Mirror to policy-based, and for a couple of reasons. Number one is it automates pretty much everything that you do. And when you tell it you want to mirror it from point A to point B, there's no more do you have to set up all of the consistency groups and all those other things that you got to do in the past and all those relationships. You don't have to do that. It's just really a point and click, and it's all done behind the covers there with the system itself. That's one reason. The second reason is it actually has increased the performance of our capability, especially when we look at doing IP replication and those between sites or maybe even between items within our same location. But it is provided us better performance, and then it really has made it easy. It's become the easy sort of button for us. So how do I get FlashGrid? I think we talked about this before. Anytime that you upgrade your controller, any new controller that you get that's 8.7 and above, you will get FlashGrid. You'll have the ability to use FlashGrid. And again, the upgrades to it and the functionality to it increase every time that we upgrade the software. So when the code is available, you have all that form, function, and feature that would go up there. Again, this also works with the SVC. I don't want to undermine kind of the grandfather that's here in terms of the sound volume controller. And we can do today up to 8 single groups, right? So we used to cluster systems together where we take multiple different like systems and we would cluster those together. We're flattening out that infrastructure now. And what we're doing is we're taking and making single IO groups, and then those IO groups can participate in a grid. Today we've got 8. I think by midsummer we'll be up to 32 physical devices in a grid, and it's going to actually go beyond that as well. In terms of partitions, then we can do up to 4 partitions today, and that's going to actually expand out to 8 as well. And so we will have additional partition capability within there. So, but today you could create 4 physical partitions, which could represent a load or maybe a site or maybe an application, those sort of things, as you know. So you can grow where you need to and when you need to, and you can optimize then the capacity and the performance based on the controller or the controller type or the drive type that you're using. So in summary, in the FlashSystem 200, why the FlashSystem 200? Because it's extremely cost effective. When we look at price performance, like we showed you before, there's really nobody that provides the price performance. They're using standard QLC. We're using our FlashCore modules that provide many benefits as compared to anything that you can get off the shelf today in terms of ransomware threat detection, compression, compaction, quantum safe encryption, the list goes on. So extremely cost effective. It's extremely dense. Again, 1.1 petabyte of raw capacity. And so in that 2U box, we can get really up to about 2.3 petabytes of capacity in a 2U, utilizing the 3-to-1 and then the rack space capability too. So we can compress hybrid configurations into much smaller footprint. Extremely sustainable. When we look at power efficiency, I don't think there's anybody in the marketplace that is as green as IBM is. It is FlashGrid optimized. It's using our enhanced QLC rather than the standard off-the-shelf, common off-the-shelf NVMe QLC drives. So you're getting the best of breed in terms of media. And then ultimately, from a protected perspective, we'll guarantee that you can detect in less than a minute, and we'll also guarantee that you can recover in less than a minute. There's nobody else providing that guarantee. So what's your call to action here? We should be looking for clients that have infrastructure or needs in their infrastructure. I would say probably 500 terabytes and more. It's 1 petabyte here, but I think 500 terabytes is probably a great place to start looking as well. If you got clients that are looking for advanced cyber resiliency, the C200 be a great box there. And then again, when you just look at the rack capability in terms of being able to put these in a rack, you can get extremely dense over time. You can also look at the different personas or highlight kind of the areas of interest that each of these businesses are in terms of infrastructure management, in terms of price performance. What are they looking at from those particular things? Total cost of ownership. When we look at the C200 as compared to the value and the things that you get, certainly is a leader there. And then when you're looking at cyber resiliency, could I provide cyber resiliency to a particular kind of workload? And the answer is yes, because we can detect on ransomware threats utilizing the FlashCore 4s. So again, what kind of workloads, data repositories, backup, streaming, medical imaging. As a matter of fact, I've got several clients that are looking at this from a medical imaging perspective as well. I've also teamed with a third party to create kind of a NAS offering utilizing the C200 because it doesn't have to be super fast. It's just got to be good enough, right? But the big thing here would be is let's not go after 5300 opportunities. It's not a 5300 replacement box. And it really has a distinct set of use cases. It's really been tuned for larger block sequential reads and writes. And so there'll be some sales plays that you'll see here that will be coming out. I'm going to change gears here a little bit, and we're going to look at IBM just announced this is kind of hot off the press. I don't have all of the uh, uh, I guess total information on this. This was announced last week, Friday. We are coming out with some 5300 value bundles, and these are for smaller clients. So if you're looking at kind of 9 TB effective, 1928, that kind of fills in the gap very nicely as compared to say a 5045 that has multiple or lots of smaller drives in it to be able to do it. So we're trying to kind of get into that lower end market, and again, these will perform extremely well, especially when you're looking at the as you get up into the 6 4x8, that will absolutely bury that flash system for 5045 with 6 drives in it. So extremely they're smaller configurations. They're really aimed at clients that may not need a whole bunch of storage, but we value price them, and so they're a bundled package, very similar. You'll see them in eConfig like the C200 is. So as you look at this, this is where and how you would order them in eConfig here. And if you've got folks that have a lot of 5045, 5030s, 5015s, 5010s, 5035s, maybe even, this might be a good fit for them in terms of replacing what they've got on the floor today as well. This is the North American Volume Flash team. There's people that are probably assigned to your folks all over the country, and I just wanted to introduce them to you. We're under a new leader this year, so Mike Flint, many of you might know Mike Flint, but that's kind of our whole entire team. I take care of the Southwest, although I will answer the phone for pretty much anybody that calls me that needs help, and I think that everybody on our team obviously is the same way. And with that, I think, oh, one last thing. So we do have a series that we do every Thursday called Flash Plus in a Flash. It used to be Flash in a Flash, but we're going to expand that to multiple different types of technologies and discussions that we have moving forward. And so you can register here on the site right there, and you'll be invited. I'm going to be doing one on a 5300 this week here on there. I did the what we do best on Flash last week, and so Sanjay will finish out the physical a month for us there. And with that, I'm going to hand it back over to Cheryl and to Mark.
Thank you very much, Todd. I know we went over the time, but guys, it was so much information that we wanted to get to you. And I hope that this was great information. I want to call out Bob Facina, who stated from HBAR, who said, Cheryl, I need that presentation now for an opportunity. So thanks, Bob, for being on the call. And thanks to the Converge team for also jumping on. This information will be sent out to you, the presentation. I just want to briefly say that Ingram Micro also has professional services that can be wrapped around these solution IBM solutions to include as he talked about, the NIST framework from a security perspective. We have penetration testing. If you would like any more information on any of IBM professional services, please let myself or Mark Miller know, and we will make sure we get that information to you. Are there any questions for Todd? Awesome. With that, Todd, thank you so very much. This was excellent. One of the best storage presentations I have ever sat through. So I was also hearing that from my business partners and internal team members. So thank you so much. We really appreciate you.
Thank you so much for having me. I look forward to maybe perhaps doing this again in the future.
Awesome. Thank you so much. Have a good one.